Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the Measurement Readiness Dashboard, the system that tells advertisers whether they can actually trust their campaign measurement before they spend a single dollar. We'll cover how platforms like Google Ads, Meta Ads Manager, and enterprise marketing clouds validate pixels, SDKs, conversion APIs, consent, and attribution windows. Whether you're preparing for a senior engineering interview or building ad infrastructure at scale, this one is for you. Let's get into it. Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the Measurement Readiness Dashboard, the system that tells advertisers whether they can actually trust their campaign measurement before they spend a single dollar. If you have ever wondered how platforms like Google Ads, Meta Ads Manager, or enterprise marketing clouds validate pixels, SDKs, conversion APIs, consent configuration, and attribution windows, this video is for you. We'll walk through the functional requirements, non-functional requirements, system architecture, end-to-end user journey, core models, low-level design, and the trade-offs that come up in a senior system design interview. Whether you are preparing for a FANG interview or building ad infrastructure, let's get into it. Here is the core problem. A marketer launches a multi-million-dollar campaign across web, mobile, connected TV, and offline channels. They expect clean attribution, accurate return on ad spend, and fast optimization. But behind the scenes, the measurement stack is fragile. A conversion pixel is missing on the checkout page. The mobile SDK is on an old version. The consent banner is blocking event collection in one region. The server-side conversion API credential expired. The attribution window changed. Any one of these issues silently corrupts the data, and by the time the dashboard shows weird numbers, the budget is already spent. The business needs a proactive measurement readiness dashboard that continuously audits the data collection pipeline, scores readiness, surfaces issues, and recommends fixes before the campaign goes live or before spend is wasted. Let's walk through the functional requirements. First, the dashboard must connect to all data sources: web pixels, mobile SDKs, server-side conversion APIs, customer relationship management systems, offline data uploads, and consent management platforms. Second, it must run a comprehensive readiness audit against a configurable checklist of requirements, such as pixel presence, event schema correctness, required parameters, SDK version, consent status, and identity resolution setup. Third, it must compute a readiness score for each advertiser, campaign, channel, and region, with drill-down capability. Fourth, it must provide actionable recommendations ranked by business impact, like fix the purchase pixel before launch or upgrade the SDK to capture post-install events. Fifth, it must support alerting and notifications through email, Slack, or in-app messages, plus a remediation workflow that tracks whether each issue has been fixed, dismissed, or is still open. These 5 capabilities make the dashboard useful, not just informative. Now the non-functional requirements. The dashboard must be near real-time. A readiness issue should surface within minutes of detection, not hours or days. The audit itself must be fast because large advertisers can have hundreds of websites, apps, and campaigns. The scoring must be accurate. A false critical alert causes panic and alert fatigue, while a missed critical alert causes money loss. The system must scale horizontally to support tens of thousands of advertisers and millions of audit objects. Data freshness and consistency matter, because the dashboard reads from production telemetry pipelines. The system must be secure since it touches advertiser pixels, credentials, and potentially first-party data. And finally, it must be highly available because campaign launches happen around the clock and in every time zone. Here is the high-level system architecture. On the left, data collectors ingest signals from the advertiser's ecosystem: pixel beacons, SDK events, server-side conversion events, customer data platform feeds, and platform configuration APIs. These events flow through a load balancer and API gateway into a Kafka ingestion layer. A stream processor validates schemas, detects anomalies, and emits readiness events into a hot serving store. A separate batch auditor runs scheduled jobs against the full configuration state, computes readiness scores, and updates the dashboard database. The dashboard application serves the user interface, drill-down reports, and remediation tracking. An alerting service consumes readiness events and sends notifications based on user-configured rules. The analytics backend stores historical readiness trends and supports executive reporting. The key metrics to memorize cold. Overall readiness score, usually 0 to 100, averaged across advertisers or campaigns. Pixel coverage percentage, which measures the fraction of required pages where the pixel fires correctly. Event schema compliance rate, the percentage of events that match the expected schema and contain required parameters. Consent capture rate, the fraction of users for whom consent is properly collected and honored. Data latency, the time from an event occurring to it appearing in the dashboard. Alert signal-to-noise ratio, which measures how many alerts are real versus false. And remediation time, how long it takes an advertiser to resolve an open issue. These metrics are what the business actually cares about. Let's trace the end-to-end user journey. A performance marketer at a retail brand opens the Measurement Readiness Dashboard before launching a holiday campaign. The dashboard shows an overall readiness score of 72 out of 100. She drills into the e-commerce channel and sees that the purchase pixel is firing, but the Add to Cart event is missing the product category parameter. The consent banner in the European region is suppressing 20% of events, and the mobile SDK is 2 versions behind. The dashboard ranks the issues by projected revenue impact and gives her one-click remediation links. She fixes the pixel configuration, updates the consent flow, and schedules the SDK upgrade. Within minutes, the dashboard re-audits, the score rises to 94, and she launches the campaign with confidence. The core models and algorithms. The rule engine evaluates each readiness requirement against the current state of the advertiser's measurement stack. Rules can be binary like pixel present or absent, or scored like schema completeness or data freshness. The dependency graph models relationships between components. A missing conversion API credential may block server-side events, which may reduce attribution accuracy. Health checks are scheduled probes that verify endpoints, SDK versions, and event volume baselines. Readiness scoring combines weighted rule outcomes into a single score, with weights reflecting business impact. Anomaly detection flags sudden drops in event volume or changes in schema distribution. Remediation tracking uses a state machine that moves issues from open to in progress to resolved or dismissed. The key trade-off is sensitivity versus specificity. Aggressive detection finds more issues but creates alert fatigue, while conservative detection misses real problems. Now the low-level design deep dive. The audit pipeline is implemented as a directed acyclic graph of tasks. Each task is a unit of work, such as fetch pixel configuration, validate event schema, or check consent status. Tasks are distributed across workers, with retries and idempotency. The results are stored in a readiness state table keyed by advertiser, channel, object, and rule. The scoring service reads the state table, applies rule weights, and computes scores at multiple levels: rule, object, channel, and advertiser. The dashboard API supports filtering, aggregation, and time series queries. Alerts are generated when a rule transitions from passing to failing, or when a score drops below a threshold. Notifications are templated and routed through channels configured by the user. For large advertisers, the system supports audit partitioning and incremental scoring to keep recomputation fast. Key takeaways for your interview. First, a measurement readiness dashboard is an audit and observability system, not just a reporting dashboard, so emphasize rule engines, health checks, and remediation workflows. Second, always distinguish between real-time streaming checks and batch configuration audits, and explain why both are needed. Third, readiness scoring is fundamentally a weighted aggregation problem, so be ready to discuss how to set weights and handle missing data. Fourth, the hardest design challenge is balancing sensitivity and specificity to avoid alert fatigue while catching real issues. Fifth, security and privacy are critical because the system touches pixels, credentials, and user data, so mention encryption, access control, and consent-aware audit logic. If you can walk through this system with these 5 points, you will signal strong senior-level design thinking. That's it for the Measurement Readiness Dashboard. If this helped, like and subscribe, and I'll see you in the next one at Cloud Wizard. And that's a wrap on the Measurement Readiness Dashboard. We covered the full picture, from data collectors and readiness audits through rule engines, scoring, alerting, and the low-level design of the audit DAG and state table. If this video helped you, please hit that subscribe button and the bell icon so you never miss a new system design video. Drop your questions in the comments below. I read every single one. See you in the next one at Cloud Wizard.